Hello guys, in this video we are going to see about how to find the dimensional quantity of certain physical quantities. So here four physical quantities are mentioned. One is the universal gravitational constant, the second one is surface tension, and the third one is thermal conductivity, and the final one is coefficient of viscosity. So for this we should know the exact equation of that particular physical quantity. So in the first case, we can have the universal gas constant, sorry, gravitational constant. So if two heavenly bodies are there with mass m1 and m2, there should be a gravitational force in between, and it is mentioned in terms of constant. So the universal gas gravitational constant, it is g. So g is equal to f r square. We rearrange that formula, f r square divided by m1 into m2. So now you can see that for force, in the previous video I have derived that dimensional formula. It is mlt raised to minus 2. For r square, it is mentioned in terms of length, so l square. And the mass of the two bodies, it is m and m, it is m square. Therefore, you will get the final value here as m raised to minus 1 L cube m raised to minus 1 L cube t raised to minus 2. So that is the final answer for this universal gravitational constant. So what I have mentioned here also. And second one is surface tension. You know that every liquid has its own surface tension based on the viscosity and all. So here the surface tension, this formula is especially for while you meant to do an experiment with the help of a capillary tube, that is the capillary action of fluid. So this is a formula, S is equal to rho g r h divided by 2. So rho is the density of the liquid, and g is acceleration due to gravity, r is the radius of the capillary tube, and h is the height of the capillary, sorry, height of the liquid that is entering into the capillary tube. So for example, if water, it can reach up to this, kerosene it may up to this. So you can mention the height, say for h1 here and for h2 here. Okay, fine. So this is how it is find. Then you can mention this for rho, it is density, mass by volume, so m by L cube. And for g, it is mentioned as the last meter per second square, so L by T square. And for r, it is L, and for h is also L. Okay, so and you can cancel this L cube. Here also 3 L's are there. You can cancel this. Finally, you will get the answer as mt raised to minus 2. Hope you understood this. And then let us move on to the thermal conductivity. For thermal conductivity, you can see this is the formula. The amount of heat that is mentioned as Q pass through a material of distance or length d, okay, per unit area of cross section, per unit temperature gradient, per unit time. So this is the formula. So from this equation you can apply this for Q. You can mention as m L square t raised to minus 2. ml square t raised to minus 2. And for d, you can put an L here. So we will get this L square and L square will get cancelled. Here a t raised to minus 2 is there. So when you take this t to the numerator, it will become t raised to minus 3. And k, if you take that, you can have k raised to minus 1. So the final dimensional formula is m L t raised to minus 3 k raised to minus 1. So this is the dimensional formula for thermal conductivity. So hope you got some clear picture now. And the last one is to find the dimensional formula for coefficient of viscosity. So for coefficient of viscosity, you have to write the formula like this. F is equal to minus eta into A multiplied by V2 minus V1 by X2 minus X1. Eta is the coefficient of viscosity. A is the area of cross section, and V2 and V1. So if you have two different layers of liquid, it is the volume of the the velocity of the velocity in the first liquid and velocity in the second liquid, and x2 minus x1, that is the distance between the two layers of the liquid. So you can have this F is equal to ml to t raised to minus 2, already you know. So eta, and here for A you have mentioned as L square, and here L by T for V2 minus V1 by X2 minus X1. For V2 minus V1, that is nothing but the velocity. Velocity is mentioned as displacement by time, so L by T already mentioned, and divided by X2 minus X1, it is the distance, so L. And cancelling this L and L, so we will get eta into L square by T. Now eta is equal to, rearranging this, ml t is raised to minus 2, this will go to the numerator, into T divided by L square. So this L square, this will get cancelled, so m L raised to minus 1, and T, this becomes T raised to minus 1. So eta is equal to, so this is the dimensional formula. Hope you understood how to find the dimensional formula for different physical quantities. You might have got some clear picture. Let us meet in the next video. Thank you.